Good morning, students.
Good morning, ma'am.
So now let's start. In the previous class, already I had started the code optimization. What is the meaning of code optimization? So basically, the code optimization is nothing but a program transformation technique which tries to improve the code, that is the intermediate code, by making it to consume less number of resources, like it is taking less CPU time, as well as memory consumption should be less, and it is going to deliver with a higher speed. Then you can say it is the role of the code optimizer. So basically, what happened, for example, when we are going to perform the translation of the source program to the object program. We have the source program. We have the source program. So first of all, we have to convert it to the intermediate code in some intermediate representation by the intermediate code generation. Then from this intermediate code generation, you are going to the output is the object program. Object program. So in this case, the object program is nothing but the assembly level code. So what happened for this given source program? If this is the source program, we have number of object programs. We have number of object programs. Let it is OP1, OP2, object program 1, object program 2, object program 3. Okay, so we can say this the one to many mapping for a given source program. We have number of object programs for the same source program. Okay, that means whatever the computation by all these object programs is same. But for example, this object program, it is the normal assembly code, but this object program is taking less number of resources. So the second object program is taking less number of resources. Always it is going to give you the better execution time. Then which object program you have to choose, whether the object program 1 or object program 2. Which one is better? Am I audible? Got the question? So anyone is attending in the class? Respond.
Ma'am, object program 2.
Object program 2 or object program 1, that is object program 1, it is the simple assembly code that is generated from the given ICG, whereas the object program 2, it is taking less number of resources like your processor time, memory consumption, and it is also giving you the that is higher speed, the execution time is better, right? So you can prefer object program 2. Okay, so when you are going to perform code optimization, it is also you are paying something. That is, you have to pay for this code optimization. Where you have to prefer whether it is object program 1 or 2. It depends on the situation. It depends on the situation. For example, we have written a program that is only executed. You are expecting the program, it should be executed for only very few number of times, maybe once, maybe twice, like this. So is code optimization is beneficial? अगर ये वाला मेरा प्रोग्राम एक है 2 बार रन होगा तो कोड ऑप्टिमाइजेशन बेनिफिशियल होगा क्या? क्योंकि कोड ऑप्टिमाइजेशन के लिए नंबर ऑफ थिंग यू हैव टू पे आल्सो फॉर दैट. So is code optimization is beneficial?
No, ma'am.
Simple.
Simple.
So if it is simple one, because you can prefer the simple one. So it depends on the situation. But for example, you need an object program that is to be executed for indefinite number of times. It should be run forever. Okay, so it is, for example, you need a code that should be executed for number of times, multiple number of times. Okay, or it is, you can say this the infinite number of times. Then whatever the money you have paid for this code optimization, so it will be paid back. Okay, even if the execution time you are just reducing or just enhancing some code optimization, which is improving the execution time. So at that case, code optimization will give you the better result. Okay, so at that time, code optimization will give you the better result. So that means it depends on the situation whether the program has to be executed for few times or for many number of times. If it is many number of times for indefinite period, for example, so code optimization you have to pay something for the code optimization. As a result, you get or improvise that execution time. At that case, code optimization is playing a vital role. Okay. Now let's see what are the different code optimization you can perform. So these clear parts, I'll share this word file with you. You have to read all these things. So optimization, it is two types. One is the machine dependent, another is the machine independent. So basically, as a programmer, we have to concentrate on the machine independent optimization. Okay. So machine independent optimization, that means we have to focus for the loop optimization as well as some optimizations. Before optimization and after optimization, you get the same output. So these are the machine independent optimizations. Or we can say these are the principal sources of the optimization. That is the machine dependent and independent optimization. So if we compare both these types of optimization, you may get the 2 marks question. What is the just compare machine dependent and independent optimization. So you have to write all these points. In machine independent optimization, it is not involving any CPU registers or any kind of memory locations. It is not needed or required for the machine independent optimization. Whereas in the machine dependent optimization, it is involving whatever the CPU registers. That means you have to completely aware about the target machine architecture. Okay. And depending on what kind of register structure, what is the addressing mode, then you can perform the machine dependent optimizations. But now in my today's class, just I'll focus on the machine independent optimizations. So machine independent optimizations, we can broadly it is divided into 2 categories. One is the function preserving transformation, another one is the loop optimization. So again, function preserving transformation means just you are focusing about some functionality and try to improve some code within that block. So we can say that is called as the function preserving transformation. So which is nothing but it is going to improve some part of the program without changing the functionality that it computes. So basically the examples of function preserving transformations are all these things. What is constant folding? What is common sub-expression elimination? What is copy propagation? Dead code elimination? All these are the examples of function preserving transformations. Now let us see the first example, first category of optimization, that is called as the constant folding. So in constant folding, what happens? If the expression generates a constant value, so instead of performing its calculation again and again, we can calculate it once and assign it. In this case, for example, we are going to perform a equal to pi by 2. So instead of computing this division operation again and again, so what we can do, we can just put what is the value this division operation results. So it can be replaced by a equal to simple constant value. So that means as a result, you are eliminating that division operation if the statement is executed number of times. Okay, so it is going to save you the execution time. So this is called as the constant folding. So all of you clear what is constant folding? This is called as the constant folding. So constant folding means instead of performing that calculation, just the result a constant way, simply you can do it once. Simply we can do it once and we can assign the variable by that constant value. For example, let I have another example. Let x equal to that is x equal to 2 into 6 plus 10. So by constant folding, what is the value we can assign now? अगर ये वाला statement है, so by the constant apply after applying the constant folding, so what is the value of x?
22.
X equal to, so just compute it once. So instead of at the wrong time again you have to perform the multiplication, then after addition, all these things. Just at the time of comparison, just compute it and assign that value to let it is 22. So this is called as the constant folding. As a result, you are going to perform some kind of that is improving the code, and it is going to reduces the runtime also. So next type of optimization, which is machine independent, that optimization is called as the common sub-expression elimination. So we can say the common sub-expression elimination in the code generation stage already we know. So by which one we can perform this one? By which technique we can find out the common sub-expression elimination? Anyone can tell me? Common sub-expression elimination. What is the technique used? By which technique we can find the common sub-expression? Already in the code optimization, I have discussed a number of times. Yeah, asking the class who are present over here, tell me the common sub-expression elimination. So by the DAG. So what is that?
Directed acyclic graph.
So by using this graph, what happens? If some value is there, let t equal to 4 into I. T equal to 4 into I. If some value is there for the second time computation, whether you are computing again or you are using this value. For example, it is
Yes,
4
ma'am.
into I and it is stored by the variable T1. For example, another statement that is T3 equal to 4 into I again. And in between this T1 to T3, the value of I is not changed. Then what we can do, instead of computing 4 into I again, you are just assigning, there is the assignment statement, that is T3 equal to T1. Yes or no? So
Yes,
this
ma'am.
one is called as the common sub-expression elimination, and that technique or the graph that is used, it is called as the directed acyclic graph. So simply I'm going to give you the example. See here. So these are the different three address statements, sequence of three address statements. So here you see T1 and T4. जिसका value same है, that is 4 into I, 4 into I. And between T1 to T4, just a minute. Okay, now you see, for example, am I audible, students?
Yes, ma'am.
So for example, these are the statements, the address statement, and T1 and T4 जिसका value same है, that is 4 into I. So instead of computing 4 into I again, that is you can use the value of T1 here. So here you see T4. So T4 is used in the last statement. So you can write B of T1. B of T1. That is T1 is nothing but 4 into I. So in this way, you can find out if any kind of common sub-expression is there. This value already computed here, and this value is used further. So you can for that purpose, the DAG is internally, that algorithm is run internally. So it is going to find out the common sub-expressions and it is going to eliminate some temporaries for the computation. So this is also another way how we can improvise our code by performing or detecting the common sub-expressions and eliminating all these expressions. So this is another example where B into C is the common sub-expression, and instead of computing B into C again and again, just you are using the value that is stored in the temp variable. So this is another example of common sub-expression. So another thing is, another type of optimization is copy propagation. So copy propagation, we can say it is maybe the constant propagation, or we can say it is the variable propagation. So what is a constant propagation and what is variable propagation? So in this case, you see, just I'm going to discuss you all the examples to read all the theory daily. So in the copy propagation, just you are copying the values. For example, x equal to pi, and a value depends on the value of x. So a equal to pi into r into r. So now x is eliminated. Okay. So just put the value of x in the further or next statement. As a result, this statement can be omitted. So this is called as the there is variable propagation. So here the variable is propagated. So in this case, the variable is propagated. But in case of constant propagation, for example, what is constant propagation? Let x equal to 2, y equal to 3, Z equal to x plus y. Z equal to x plus y. Then what happens? Just you have to put that constant values in where when Z is evaluated. If it depends on some constant values, already जिसका value already defined है and it is constant, so you can put Z equal to 2 plus 3. Z equal to 2 plus 3. So it is called as the constant propagation. Right? Again 2 plus 3, we can say it is the constant folding. It is, we can say it is constant folding. So as a result, these three statements ultimately it is reduced to a single statement. So जिसका value है Z equal to simply 2 plus 3 equal to 5. So there is no need of all these things. Simply you can put Z equal to 5. So here this is the purpose of the constant folding as well as the constant propagation or variable propagation. If some constant is replaced, that is called as the constant propagation. If some variable is replaced, that is called as the variable propagation. Okay, all of you clear, students? What is copy propagation?
Ma'am, explain it again.
Copy propagation means you are just copying some value. ये जो वैल्यू है मे बी ये वाला वैल्यू वेरिएबल का वैल्यू हो सकता है और कांस्टेंट हो सकता है. देखिए x में भी some value of the variable or x is some constant, right? So when I'm going to write about, I'm using the value of x, which is pi. Pi is already defined, that is 3.14, right? So if I replace x by pi, then it is called as the that is what variable propagation. Just you are replacing, or we can say copy propagation. Simply it is copy propagation. Copy propagation. That means you are just copying whatever the constant value variable that is there, just replacing that variables by the right hand side, whatever the value that is assigned for that variable. ठीक है, ये वाला हो गया. For example, another case ये भी हो सकता है x equal to 1, y equal to 2, z equal to x plus y. तो if we apply copy propagation, तो z का वैल्यू क्या होगा? If we apply copy propagation, just you are propagating the value of x and y for computing z. So what is the value of z now?
3.
3. So z equal to 3. Sorry, z equal to 3 नहीं होगा, z equal to 1 plus 2. Z equal to 1 plus 2. So now it is a constant. So this value is, that is, it is, you have to perform the constant folding now. You have to perform the folding. So if I apply the folding operation, right? So 1 plus 2, now it is computed to 3. So z equal to 3. Propagation means just replacing the value of the variable, right? So this is called as the propagation. Folding means if the right hand side is some constant value, that is called as the, just you have to evaluate like pi by 2 or pi r square like this. If r is defined and pi value is defined, so instead of writing pi r into r, just put the value of pi and r and compute. That is called as the constant folding. So all of you clear the difference between constant folding and copy propagation? Again,
Yes,
it's
ma'am.
constant folding. Constant folding का मतलब क्या है? If some constant value is there, just you have to compute. So as a result, it is going to perform or perform the performance, improve the performance or reduce the runtime. ये वाला डिवीजन अगर runtime में compute हो गई तो ज़्यादा time लेगा. So at the compile time, just compute this operation and assign the value. Any kind of, for example, we have an operation like a equal to 5 into 2. A equal to 5 into 2. So by the constant folding, a का value क्या होगा?
10.
10. Okay, simply if the right hand side of the expression is evaluating and finally the result of the right hand side is some constant value. So by the constant folding, what you have to do, you have to compute it. So as a result, it is going to save you the runtime. It is going to reduce the runtime execution time. But in the copy propagation, क्या होगा ना, अगर कुछ value already assigned है, so and that variable's value further use हो रहा है, then you can replace that variable by that value. ठीक है? Clear, students?
Yes, ma'am, clear.
So till now, what we have discussed the common sub-expression elimination. So by the DAG, we can find out what is the common sub-expression. Then it can be eliminated. Okay. So as a result, if something is computed, do not compute it again. So as a result, we can also set the that is around that is we can improvise. We can improve the execution time also. Another way is constant holding. Constant holding means अगर तुम्हारे expression का right hand side में that value of the expression is some constant value. So just do that evaluation, then assign the result. So as a result, it is going to save or it is going to reduce the runtime. Another thing is it is called as the copy propagation. Copy propagation means if some variable is like this x equal to pi and x is used further, so in place of x we can directly put the value of pi also. And by the constant holding, अगर ये वाला value pi का value defined है, let pi equal to 3.14, right, and r equal to 2. So by the constant holding ये का value क्या होगा? By the constant holding. Copy propagation में तो ये वाला value रिप्लेस हो गया, x का value 3.14 हो जाएगा, r का value 2 हो जाएगा, ठीक है? Now by the copy propagation, a equal to 3.14 into 2 into 2, right? So this is copy propagation. And by the constant holding, what is the value of a? So you have to compute, okay, whatever the value after multiplying 3.14 into 2 into 2. So that one is the result. So by the constant holding. So constant holding करने के बाद whatever the value in the right hand side, just assign that value to the variable a. So now I hope all of you clear up to this. So next type of optimization we can perform is called as the dead code elimination. So dead code elimination means if something that is unreachable throughout the program execution, if some code, some variable that is not used, and if it is executed, the output is not never used in the further computation or further steps, then that is called as the dead code, and these type of dead codes can be eliminated to reduce the runtime also. So simply you have to eliminate the dead code. First detect the dead code and eliminate the dead codes. For example, I equal to 0, right? If I equal to 1 and this statement, the block of statements will be executed depending on the value of I. So the dead code, which one is the dead code now? Which one is the dead code now?
If condition.
If condition. ये जो पूरा सारे block of statements है for this if block. So this one will never executed because I value is already initialized to 0, and this is the next statement below this initialization statement, and within this I and this statement there is no other statements are there. So we can see this I value never changes or it will not be the value of 1. As a result, this block of code will not be executed, and simply we can eliminate instead of executing the code for this block. So this one will not be executed. Okay. So this is called as the dead code elimination. Here in this case, now tell me which one is the dead code. Already answer is in the right hand side, but now you just read all the statement and tell me why this one is the dead code. Identify and tell me. Which one is the dead code now? Occurs.
Yes, ma'am.
Which one is the dead code now? Or we can simply ignore that code.
Ma'am, that else if A is equals to B, but
Else if A equal to simply here there is the condition for A greater than B. Another
Yes,
condition is that A less than B. अगर A greater than B नहीं होगा, A less than B नहीं होगा, automatically the value is equal to B. Okay, so if value of A equal to B, the value of M equal to 0. Simply write in the else one we can equal M equal to 0.
M equals to 0.
M equal to 0 and eliminate this one and the remaining of the else part. Okay. So in this way,
Yes,
you have to find out the dead codes, that is a number of times you execute the program code, so never that code will be executed. So you have to detect all the statements and eliminate it. Right. So next is, so these are called as the function preserving transformations. Function preserving transformation means if you apply all these optimization techniques to simply three address statement, before and after you get the functionality is never changed. You get the same output. You better reduce the number of statements. You better reduce the runtime. All these things you can do easily by applying all these function preserving transformations. So another important optimization is loop optimization. So loop optimization, or we can say it is the rule. It states that 90% of our program, the execution time, is spending the 10% of the code. If in my program we have a loop is there, so maximum execution time it is spending for executing that code. So it is very important rule. It's called as the 90% of the time is spending the 10% of the code, and this 10% of the code is nothing but the loops. It is basically executing. It is devoting more time for the execution of the loop, or it is called as the 90-10% loop. So inner loops where the program is going to spend more of the program execution time. So running time of the program may be improved if we decrease the number of instructions in the inner loop. If, for example, for let we have a statement for I equal to 0, and this loop is executed I less than equal to 10,000. Number of times it is executed I plus plus. And inside this statement that I have an expression or statement that is not dependent on this variable I. Simply easily happily we can move this statement outside the for loop. Outside the for loop. Let it is A equal to B plus C, which is not depending on this loop counter variable. So happily we can move this statement outside the for loop. That means instead of executing this statement 1,000 or 10,000 number of times, so now it is executed only once. So as a result, we can reduce the runtime also, we can improve the execution time. So now let's see what are the different loop optimizations we can perform. So different loop optimizations are, it is called as the core motion or induction variable elimination, or we can say it is the reduction in strength. So these are the different techniques that can be applicable inside the loop. So one is the core motion, one is the induction variable elimination, one is the reduction in strength. So these 3 points. Core motion okay. Induction variable elimination, that means we have to find out which variables are the induction variables. Then reduction in strength. Reduction in strength means just you have to replace the expensive statements by the cheaper one. So this is called the reduction in strength. Now let's see one by one. So first one is the induction variable elimination. It is also important. What do you mean by induction variable, or how to find out which variable is the induction variable? Then how can we eliminate these induction variables? Induction variable is a variable which is increased or decreased by a fixed amount on each and every iteration of the loop, or we can say it is the linear function of another induction variable. Here, this is the example. I equal to 1, I less than equal to 10, and j value equal to 2 into I. So that means we can say both I and j. So these are in the arithmetic progression. J value and I value. So these are having, we can say it is they are related linearly, or we can say they are in the arithmetic progression, both I and j. So I and j both are in the arithmetic progression. It can be written as. So how can we replace? So now simply we can replace the loop by eliminating the value of I by. So now simply I can write j equal to 2, j less than equal to 20, j equal to j plus 2, and whatever the other statements are present inside the loop, it can be executed. So here I and j, so these are the induction variables. So I and j, these are the induction variables because they are in the arithmetic progression. So for the value of I, the value of j is twice the value of I. So we can replace the value of I by replacing the code like this. Simply I value is not used. Okay. So by the j variable, we can rewrite the loop. By this one, it is called as the induction variable and eliminating the induction variable. Clear? What is induction variable and how to eliminate the induction variable? Or let's take another example. For example, we have a statement like this. That three address code that we have generated. Let t1 equal to 4 into I. Another statement is I equal to I plus 1. I equal to I plus 1. If I is less than equal to 20, go to some line. If I is less than equal to 20, go to some line. So here you can who can say which are the induction variable or which variables are in the arithmetic progression. Which variables are in the arithmetic progression?
T1 and I.
T1 and I. So here both T1 and I, so these are in the arithmetic progression. If the value of I, and this is T1. So I value, it depends on let I equal to, initially I equal to 1 से start हो रहा है. So if I equal to 1, T1 equal to 4, I equal to 2, T1 equal to 8, like this. I equal to 20, T1 equal to 80. So here I and T1 both are in the arithmetic progression. They are linearly dependent with each other. So we can say these two variables are the induction variables. Now we can say how can we rewrite these statements? Simply you have to eliminate any one variable and write the same code with the help of the second variable. Is anything? How to rewrite the code so that I variable is eliminated, and by the T1 variable we have to rewrite the code. Is it? Let T1 equal to 0. Simply instead of 4 into I, what we have to write? T1 equal to T1 plus 4. T1 equal to T1 plus 4. Okay. If statement में condition क्या होगा? If T1 equal to 0, initialize T1 equal to 0, next statement में क्या होगा? T1 equal to T1 plus 4, so T1 4 हो गया. So this one is completely eliminated. मतलब what will be the condition to at the last iteration में condition of T1 क्या होगा? If T1 is
T1 less than
equal to 76.
80.
76 होगा ना, then T1 equal to, for example ये वाला और क्योंकि number of
Yes,
times T1
ma'am.
equal to 4 पर 0 तो नहीं होगा ना, so this is initialized once and these lines of code will be executed for 20 number of times. So if T1 is less than equal to 80 होगा या 76 होगा? T1 is less than equal to 76. Okay, T1 is less than equal to 76. Then go to target statement. So here this is called as the determining or finding which one is the induction variable and eliminating one variable and use the same number of statements with the help of the rest variable, another variable. That is called as the induction variable and elimination of the induction variable. So in this case, simply we are eliminating the I variable and replace the whole code with the help of the T1. Clear? Clear all of you?
Yes, ma'am.
So here also, जैसे कि ये वाला I and J both are in the arithmetic progression, we simply eliminate or ignore the variable I and rewrite the same code with the help of the J variable. It is called as the induction variable and eliminating the induction variable. You see this one, how this how the induction variable, finding the induction variable and how it is written. So another type of optimization that is called as the code motion. Code motion means simply you are moving some code out of the loop. Okay. So just you are to decrease the number of statements inside the loop. Just you have to find out the code that is not dependent on the loop counter variable or that is independent of that loop. So just you have to find out which one that independent of this loop iteration. So you have to find it out and you have to take it out of the loop. Okay, so this transformation takes an expression that gives the same result independent of the number of times that loop is executed, and it is going to place the expression before the loop. It's going to place the expression before the loop. It is also called as the loop invariant computation. That means that statement is basically not depending on the loop variable, or you can say it is the loop invariant computation. So this one is a good example of what is code motion or loop invariant computation. For example, at the end में क्या है? While I is less than equal to limit minus 2, right? So by the code motion, we can also rewrite the statement by, because why we are calculating limit minus 2 n number of times, or the number of times this while loop will be executed, it should be evaluated only once. That is t equal to limit minus 2 while I is less than equal to t. So which one is better, second approach or first approach?
Second.
Second one. So instead of computing that statement which is not dependent on the loop counter variable, so you have to simply execute once and use the variable n number of times. So this is the example of code motion. Similarly, also we can give another example, like for example we have a loop for I equal to 1, I less than equal to max minus 1, I plus plus, count equal to count plus count equal to count plus I, count equal to c plus I. Count equal to count plus I means this statement is completely dependent on the loop counter variable. So now tell me, how can we improve this code? How can we improve this code?
T equals to max minus 1.
We can rewrite the code by t equal to max minus 1. So here the for loop can be that is changed as for I equal to 1, I less than equal to 1, I less than equal to I plus plus, and for the other loop. So this is called as the loop invariant computation. And code motion is if inside the loop if any statement, for example, it is another statement equal to a equal to b plus c is there. So you can also move the statement out of the loop. So this is called as the code motion. This is another example. Now you can see inside the do loop a equal to 5. Okay. So it is not depending on that is if we put this statement before this loop, we also get the same result. Okay, so we can say it is called as the code motion. You can move the statements that is present inside the loop. You can put it before the loop and execute the statements that is dependent on this item. So here it is called as this concept is called as the code motion. So another operation that you can do, that is called the reduction in strength. Reduction in strength means just you are going to replace the expensive operations by the equivalent cheaper one. That means which is taking less CPU cycles. If any operation is taking n number of CPU cycles, and another operation that can be replaced with this operation and it is taking less number of CPU cycles, then you can also replace the expensive operation by the cheaper one. So that concept is called as the reduction in strength. For example, x square, that is if the exponent operation, the power operation it is taking, it is cheaper to implement the x into x, because that exponentiation operation it is going to call the exponential subroutine. So you can also replace this operation by the multiplication of two variables. If it is x4, then we can also replace by x into x into x into x. So this type of operation is called the reduction in strength. Other operations by like the multiplication and division operation can be replaced by the addition and subtraction respectively. That is, if the multiplication and division they are taking, these are the first pair operations. So you can replace any kind of multiplication, that is a into a equal to a into 2. So So we can replace a into a plus 2, that is a plus a. So we can replace all the multiplication and division operations by the addition and subtraction operations. Also another way we can improve or we can replace by the cheaper code by like the left shift and the right shift operator. If any operation, that is the multiplication operation by 2. Okay, so it is shifting, that is you are going to already know by the left shift operator, just you are multiplying the result by the value 2, and for the right shift operator you are dividing the value by the 2. So by this concept also you can replace the multiplication and division operation by the left shift and the right shift operator, and these are the cheaper one, and these are the costlier compared to the shift operators. Okay, so now just if we conclude all these things, so depending on the situation, you have to perform the loop optimization. Loop optimization means whether that program is supposed to be executed for how many times. If it is to be executed for 1 or 2 times, so better do not perform any kind of optimization. Rather, what you have to do, you have to go for as it is. But if that's some program that is to be executed indefinitely, so loop optimization is must. Okay, so you may improve very less amount of code, but as a result, what is that? And so as a result, when you are executing that code for number of times, so it will get give you the better result. So number of code optimizations as we have seen, it is of 2 types. One is the machine dependent, another is the machine independent optimization. So machine dependent, depending on the target machine architecture, whereas the machine independent, it is not involved in any kind of CPU registers or the memory locations. So now in this class, today's class, we focused on all the types of machine independent optimizations, which are of again 2 types. One is the function preserving, another one is the loop optimization. So in function preserving, already we have discussed these are the number of ways we can improve a block of code by the constant holding, common subexpression elimination, copy propagation, dead code elimination. So any doubt in any point? Any point in doubt?
No, ma'am.
So in next class, I'll discuss what are the other loop optimization techniques. So these are the how can we reduce the frequency. So this is also you can see sin x by cos x. So we can do it once. So it is called as the code motion. Just you are using that sin x by cos x out of the loop and use it once. Another is the loop controlling, loop jamming. So different ways other loop optimizations are there. So now with the help of one example for a given 3 address code, how we are going to perform the loop optimization. So I'll discuss one by one in the next class.